Hi, in this video we'll look at how to format cells in your Excel worksheets using Python and PyXLL. We'll cover how to format the results of worksheet functions, or UDFs, how to apply formatting to Pandas data frames, writing macros to apply formatting to cells, and how you can write your own custom formatters. You'll need to have PyXLL installed. If you've not done that already, take a look at our other tutorial to see how to install PyXLL. For this video, I've got a basic PyXLL configuration. I've got the executable set to my Anaconda environment, the Python path set to my source folder, and I'm just importing a single module. One thing I've changed from the default config is this auto reload setting. By turning this on, PyXLL will automatically reload whenever I save any changes to the Python code, which just speeds things up a little bit as I don't have to keep manually clicking the reload button in Excel. When using a worksheet function in Excel, typically only the value is returned and the cell formatting has to be updated manually. A common case where this is a problem is when returning a date or a time from a worksheet function. Excel dates are shown as numbers until date formatting is applied to the cell. Another common case is when returning a table of data for a report. It can be time consuming to update the cell formatting, and that's especially true if the size of the table can change. Let's start with an example function that returns today's date. To make this an Excel worksheet function, we add the Excel func decorator, and now when we save this file it will be available to call from Excel. Because I have the auto reload setting turned on, I don't need to manually click the reload button in Excel. As expected, with no formatting, the result of this function appears as a number in Excel. We can apply formatting to this cell manually, or we can use PyXLL's cell formatting feature to do it automatically whenever the function is called. To add formatting to our function, we import PyXLL's formatter class. The formatter class can apply various types of basic formatting, including setting the number format. To format the results of this function as a date, we need a formatter that sets the number format to the date format. To use this formatter with our function, we pass it in as the formatter argument to the Excel func decorator. Now when we call this function from Excel, the formatter is automatically applied and the date is formatted as we specified with our formatter. The formatter class takes a few different options. For example, if we wanted to set the cell's interior colour, we can do that using the interior colour option. Rather than create a formatter for every combination we need, formatters can be composed by adding them together. Another common use for formatting is when returning a Pandas data frame, for example as part of a report or an interactive dashboard. We can return an entire data frame to Excel as a dynamic array or using PyXLL's auto resize feature, but without a formatter, any formatting has to be applied manually and reapplied if the data frame changes size. PyXLL can automatically format a data frame with its Dataframe formatter class. This is another type of formatter like we saw in the previous section. Like the formatter class, the Dataframe formatter has various options we can use to customize how the data frame is formatted. For example, we can change the colors, or even apply specific formatting to individual columns of the data frame. And if the data frame changes size, the formatting adjusts automatically. The same formatters we saw in the previous section can also be used from Excel macros. To write an Excel macro in Python, we use the Excel macro decorator from the PyXLL module. We also need the Excel app function to get hold of the Excel application object. If you've ever written any VBA, the Excel application object may be familiar to you. In Python, the Excel application object is exactly the same as the VBA application object, and we can use it to access the entire Excel object model. This means that we can write Python code to do anything we would have previously done using VBA. The objects in Python are the same as they are in VBA, so translating between VBA and Python isn't usually too hard. We'll write a Python function to apply some formatting to the current selection in Excel. We get the Excel application object using Excel app, and then get the current selection property in exactly the same way we would in VBA. The pixel formatter object has an apply method, but that apply method expects a pixel class XL cell. We can convert the selection range object we have into an XL cell using the fromRange static method. Now we've got the XL cell object, we can call the formatter's apply method to apply the formatting to the selection. Usually we want to apply the formatting at the same time as setting a value in XL. To set a value, we can use the value property on the XL cell object, and to apply the formatting at the same time, we pass the formatter to the options method. We can use this to write a formatted dataframe to XL in a macro function. The standard formatters provided by Pixel perform some of the most common formatting tasks, but for more advanced formatting we can write a custom formatter and use it in exactly the same way as the standard ones we've seen so far. When we looked at macros earlier, we saw that we can get the XL application object in Python, and through that access the whole XL object model. This means that whatever formatting we could do in VBA, we can also do in Python. Suppose we wanted to apply borders using a formatter. The standard formatters don't have an option for that, but we can write some Python code that will do that for us. Although we'll be writing this in Python, the VBA macro recorder is still a useful tool to see how we can do something using the XL object model. We can record a macro applying borders to the current selection and see what that looks like in VBA, and then translate that to Python code. To test this out, we'll use the XL macro decorator to expose our Python function as an XL macro. Now that's working okay, to turn it into a formatter we create our own class derived from the standard base formatter class. The formatter class has three methods that we can override in order to customize it to do exactly what we want. These are apply, apply cell, and clear. Generally we will only need to override the apply method. The apply method is called for a range in order to apply formatting to it, whereas apply cell is called for each individual cell within the range in the case we're dealing with an array formula. The clear method can be overridden if you only want some of the styles to be cleared and not all styles. By default, the clear method will clear all formatting. In our case, we just want to override the apply method. We're passed a pixel XL cell instance, but we can use the toRange method to get an XL range object from that. Then it's just a case of using the code we've already written. Now we can use our new formatter with a function to add a border to the result. We can also use this in combination with other formatters by adding them together. We've seen how formatters can be used to apply formatting to XL cells when returning values from worksheet functions and in macros. We've also seen how we can use the XL object model to apply more complex formatting, and how we can apply that in a custom formatter class. If you've got any questions about anything you've seen in this video, please contact us and we'll be happy to help.